Good morning, everyone. Thank you for joining us today for our Game Changer in the Energy Transition webinar. I'd like to start with a few words about the FACC Texas. We are a non-profit organization. We develop business connection and opportunities between France and Texas. Our organization is led by an amazing board of directors. These directors are C-level executive and business owner from different companies. We have also a very large network, and we'll build strong partnership with them. And we support large, medium, and small businesses, but also startups. If you like to join our community, we have different level of membership, and I invite you to visit our website, facctexas.com, to know more about it. And then the FACC Houston hosts more than 50 events per year, mostly webinars on the energy transition, medtech industry, innovation, entrepreneurship, career. And we have also two major events, which are the Business Excellence Award in September and the French Festival in November. Finally, I'd like to say a word about a new program we just launched this year. This is the Le Français des Affaires. It's a program with French lessons tailor-made for French business use. We have a great French certified teacher. And if you like to know about it, to get you official certification, please just send me an email. You have my contact info at the bottom of the screen. So let's start today with our webinar. We have amazing speakers. We have Pierre Levan from Iskandia Operating Energy, Marie Contou Carrere from Rice Carbon Hub, Ralph Hedel from Demeta. And then I'd like to introduce Laurent Pagnon, VP Digital External Technology at TechnipFMC. And Laurent recently joined our board as a director. So Laurent, leave you the floor. Thank you so much for being with us today.
Thank you very much, Leah. And first, thank you to the Texas French-American Chamber of Commerce for hosting the events. I'm really happy and glad to be able to participate as moderator. I'll take a few minutes to talk a little bit about energy transition and certain game changers. And then I will introduce our amazing panelists for today's discussion. So, you know, in my role as Vice President for Digital and External Technology, I'm always looking for new technologies, thinking on how TechnipFMC, how the energy industry could be impacted, could be transformed by these new technologies, challenging existing ecosystem, current ways of working. And we already know that, but there is no bigger revolution than energy transition and what is happening now in the global energy industry. There is no other mega trend, no other technology that can compete, I would say, with energy transition today. Although, you know, you could argue that digital as well is having a massive impact. And what has been fascinating, I think, is that it's now really taking off and it is accelerating. It's not anymore about wind power alone, you know, or solar. It took us a lot of time to scale these very first few technologies. I'm thinking of, for instance, biofuels, wind power, solar power, you know, to reach commercial and technical viability in order to compete with traditional energies. But we are here, and I think now our challenge to reach, you know, the ambitious Paris climate goals is to decrease the time to scale up. And I think it's really our role, you know, as you know, tech people, tech guys in the energy industry, to speed up the technical development and adoption of new energy systems and new energy solutions. Because wind, solar, biofuel, it's not enough. We know that. And we really need to decrease this scale-up time. So at TechnipFMC, and I can say honestly, we are the first one to do so, but we just disclosed our ESG and energy transition strategy. We call it, 50 by 30. It's a commitment to decrease by 50%, our carbon emissions by 2030. For us, it's already, a massive change. We have identified concrete actions, concrete levers to reach this goal, but we do have a heavy focus around new technologies and new energy ventures. And I would like to highlight, 3 big energy transition megatrends that are priorities, I think, for industry and for TechnipFMC. Because in next 10 years, there will be significant market opportunities and market growth around these 3 megatrends. I'm going to really disclose a lot about the first one, which is offshore renewables and all electric solutions, basically. And the 2 others, I think my panelists are going to talk a lot about these other 2. So if we just look quickly at offshore renewables, it's not new. Fixed offshore wind has already large install base, but it's meant to continue to grow. Offshore is really a place where you have much more space, much more resources than onshore. No human around as well in terms of HSE is very interesting. And it sounds silly to say that, but offshore is less cyclical than onshore renewables. You have more wind, basically. Wave energy is much more steady. So if you look at it, it's an unbelievable resource that we do not really exploit well today. So if we want to reach, sustainably and large-scale offshore renewables, we have as well to go for floating solutions and underwater solutions, because if we stay super close to shore, we will not be able, to reach this scale we would like to reach. So at TechnipFMC, we are looking at floating offshore technologies, subsea technologies. So obviously wave and tidal, floating wind, subsea hydrogen network, and subsea and hydrogen subsea storage, for instance. And we think, that it's critical to enable offshore renewables to find companies, to find players that will be able to be system integrator, because you need to combine many different things when you are offshore, and especially when you are, far from shore. You need to be able to have naval and floating architecture skills. You need to be able to model waves, to do simulation of waves, to have offshore project management capabilities, control system when you are so far from shore, to remotely control your system, power management for intermittency, and you need to combine all of that. So it's a massive challenge, but this is where, companies in the energy industry really have a true role to play to be able to accelerate, offshore renewables. And just as a concrete example, we are really looking actively at subsea hydrogen. What does that mean? It means that at TechnipFMC, we believe it makes sense to integrate offshore renewable electricity with subsea hydrogen storage to be able to compensate intermittency of offshore renewable, basically, and provide, a much steady power thanks to a fuel cell that could turn, hydrogen into power when we have less wind or less solar energy, basically. But to do that, you need to add on top of everything I've listed, the hydrogen management, safety, transportation, processing of hydrogen. And this is, one of the challenges we try to solve. The 2 other mega trends, in my opinion, would be obviously hydrogen and CO2. I put these 2 together because they are gas energy carriers. And I think it's going to make as well a massive revolution in the next 10 years. And it's so obvious that we need hydrogen and we need CO2 sequestration to reach Paris climate goal. And our panelists are going to talk a lot about it. And the last one that maybe we highlight a bit less, but for me, it's really around green chemicals and biofuels. We talk a little bit less maybe about these 2, but they are truly important as well. Biosourcing our economy is a massive enabler to reduce our dependency to traditional fuels. And also, and I think it's important, biofuels, green chemicals are one of the biggest engines of the circular economy to avoid waste. And these two are key, game changers, I think. Now I'm going to turn over to the panelists to launch the presentation and the session. And it's really a pleasure for me to introduce these three panelists. So our first speaker is going to be Pierre Levan. He is Chief Technology Officer of Iskandia Operating Energy. And he is also Managing Director at Vulcain since 2012, where he is responsible basically for natural resources deals, including large cross-border gold and oil and gas transactions. And previously, Pierre has founded Soyuz AM in Russia and Flam, a Swiss asset management firm dedicated to Russia HNNWIS, with particular expertise in structuring corporate transactions in the resource sectors. Our second speaker is Dr. Marie-Nathalie Contou Carrere. She's basically research advisor for industry partners and interim executive director of the Carbon Hub office of Rice University. So currently, Marie-Nathalie, she's serving as I said, interim executive director of the Carbon Hub. She's going to introduce to us this Carbon Hub. It's a public-private research initiative launched by Rice in 2019 with commitment from Shell, Prysmian, Mitsubishi, and others. And previously, Marie-Nathalie has held, different various technical and commercial positions at Ineos Olefins Polymers in the USA. And our last speaker is Ralph Hedel, and he's Chief Commercial Officer of Demeta since 2018. And prior to that, Ralph has had, a really interesting and long career in various industries, and more particularly in the field of performance materials. So for the last 12 years, basically, Ralph led the sales and marketing activities of Telen, a global leader in the segment, basically, of resin systems. And together, with his team, Ralph has opened new markets for the company in Russia, Brazil, India, Turkey, so very international background. So I'll leave the floor open now to Pierre, as our first speaker. And please, all of you, don't forget you have a Q&A at the bottom of the Zoom meeting. Please type your questions for a panelist. I will go through them, try to ask them, and that would be able, to fuel a good discussion at the end. Thank you. Pierre, floor is yours.
Thank you. Good morning, everybody. Laurent, just to correct a little bit, BIM, which is a group owning Iskandia Energy Operating, which I founded 5 years ago with my partners, is becoming so big that my involvement in Vulcain today is pretty marginal. Anyway, so what is doing BIM? We develop businesses in the energy world which leverage advanced and clean technologies. So we are really entrepreneurs, and we are really technology focused, and of course, green technology focused. So we started with TEO 5 years ago, with which we did start to buy oil assets in Texas, mature oil field, legacy fields, as said in Texas, where we did see some potential using certain technologies. And we started to apply those technologies pretty successfully. We made those fields more economic, and we are producing in a much greener way. To give you an idea, our carbon footprint is less than a third of the average of the industry. Next slide, please. So after TEO, we have started IEO, which is the operating company, concentrating all of our technology expertise. And we are now developing several other activities, including SLU Enterprise, which will be a marketplace for deep rights, Taurus, which will become our US financing arms, because so far we have been funded primarily by UK pension funds. And we are developing TET, which is a new investment vehicle, which will be focusing not only on oil and gas plays, but hydrogen, plastic to oil, and so on. Next slide, please. The type of techs, for example, in the oil and gas business we have been using, goes from physical stimulation technologies such as plasma pulse, which is a heritage Soviet technologies we have been revisiting with some Ukrainian partners, which develops very high power in the oil, in the well bore, and that generates shock waves, which clean the well and macrofracture the nil well bore. So the average increase in production is 70%, and it's totally clean. We use acid replacement, which are acid which are harmless for the crew, harmless on the equipment. They become acid, the protons are released only if they meet magnesium or calcium ions. So that's absolutely safe for the crew and safe for the equipment. We use the technology with a low to clean paraffin, a very common plug in our good old Texas fields, without using fresh water, without using highly polluting chemicals. And we all know in Texas, usually you have a well which is plugged with paraffin. You send like 80 barrels of hot water plus a bit of xylene, and life is good. And that's, of course, extremely un-environment friendly. So we replace that by other technologies, so not to use that. And we develop a number of applications of nanoparticles, say silicone, for example, nanoparticles, so which allow to reverse wettability of carbonates, or sodium silicate nanoparticles, which allow to cure aqueous phase trapping. Sorry, next slide, please. Um, of course, there are the techs, and we have been screening hundreds of techs. We have been testing dozens, and a lot of trial and fail into that, believe me. We use today 8, and we are always looking at the next we'll use this year and the ones we'll use in 2-3 years. And we see developing a number of technologies that are extremely exciting. Typically, electric fracking. We should not call it fracking, actually, that's electric shearing, to be technically precise. That's sending a very high intensity, we talk thousands of amperes, information, which allow basically to generate fractures network. So you use that between 2 wells, and that develops fracture network. And this is a potential replacement to fracking, which is of course extremely exciting, because if you do that, that's shearing, not fracking. So you don't need propans and you don't need chemicals. A step further, and that one is still at lab level, to be honest, would be to transform kerosene into synthetic oil in situ. This has been tried many times. Shell tried and it worked, but it was uneconomic. There is a team in Europe which has developed a technology that we follow very closely, using supercritical water and nanoparticles, and it seems to be able to deliver. This is something maybe we use in 2, 3, 4 years, but beyond what we do today, what we do tomorrow, we believe it's important to follow what may be a game changer for the industry in the coming years. Next slide, please. Beyond the pure oil game, obviously we started to think, okay, we have built a nice platform, we have raised more than $100 million. How can we develop the strengths into other energy? I am still on. I have something strange on my screen. Yeah, okay. Sorry. So we are using, we are developing new technologies. Sorry, my screen went blank, so I used the other one. And what can we do, which is something we understand? The one and most interesting for us is probably the natural hydrogen. Hydrogen exists in the earth like oil and gas. It's a very new industry. There is one really existing profitable player today in Africa. There are a number of developments, including in the US, and we are discussing investments in several of those opportunities. And we believe natural hydrogen exists in such amounts that it could become one of the replacement of choice for electrolysis hydrogen, as it would be much cheaper. Another option we look at is hydrogen from oil fields. Again, that's in situ reforming. It's a little bit more complicated. And the third avenue we explore is converting waste plastic into oil. And again, that's there are a couple of American businesses which are starting to do that, and we are likely to invest into those this year. So I think I'm a little bit over time. Sorry. Hello?
Yes, Pierre, you're finished, or you need
Yes,
to
yes.
conclude on something else? No, okay.
No, I'm sorry, I'm over time, so I guess I will stop here. Sorry about that.
Okay, Norris, thank you. Marie-Nathalie?
Good morning, and thank you for this opportunity to present the Carbon Hub to you guys. I really appreciate this. Thank you, the FACC. So I am the interim director of the Carbon Hub, which is led by Professor Pasquale from Rice University. So the Carbon Hub is building a zero emission future by advancing clean hydrogen and carbon materials that can slash the CO2 emissions from industry and transport. Next slide, please, Leah. So currently the world is facing this dual energy challenge. How do you meet the ever increasing energy demand while limiting the CO2 emissions to meet the targets set by the Paris Agreement? So hydrogen, I mean, the sustainability challenge is a little bit what we call the whack-a-mole problem. Yep, hit the problem on the head and you think you have a solution. No, that was still the same slide. I will tell you when to move, sorry. And actually you may have created more problems because all the issues are very much interconnected. So hydrogen is looking as a very promising clean burning energy source, but there are not really a lot of natural sources. Now I have to say not really after what Pierre said, since that I wasn't aware that there are some opportunities in Africa and some countries where there will be some natural sources of hydrogen. So there is this color expanding palette that denotes the different pathways to produce hydrogen, each with their pros and cons. So when you work with gray or blue hydrogen, you generate a waste stream of CO2. When you look at green hydrogen, you have to put a lot of energy in the process. And when you talk about turquoise hydrogen, you now have a waste stream of solid carbon instead of CO2. At the same time, the primary CO2 emission offenders are industry and transport, which account for 43% and 25% of global emissions. And the industrial sector is the hardest of all to abate because making cement and steel requires a lot of energy from fossil fuels to get the right temperatures, and it includes chemical reactions that will generate CO2. When you look at the transportation sector, one of the tactics is to improve the efficiency of the transportation fleet through lightweighting materials, lightweighting the cars by using materials such as aluminum or carbon fibers, or electrifying the vehicles to improve their efficiency. But you introduce new problems because these new materials you introduce have a much worse CO2 and energy footprint, and electrification means you're adding more cables, so you may be increasing the weight of your car. Next slide, please. So is this a catch-22 situation? Could we do something? So what the Carbon Hub says is, yes, let's go beyond turquoise hydrogen to what we call Azure hydrogen. We love the color blue. So in the same fashion as turquoise hydrogen, start from hydrocarbons, split the hydrocarbons into hydrogen and solid carbon. So the splitting process is done with heat. You don't introduce oxygen, so you don't emit CO2. And the energy you need for this process can be renewable, and it's a small fraction of the energy that is contained in the hydrogen you obtain at the end. But what we have to keep in mind here is what you do with the solid carbon. For every ton of hydrogen you make, you have 3 tons of solid carbon if you start from methane. It gets even worse if you start from other hydrocarbons. So if you click, Leah, thank you. So hydrogen is a commodity, but carbon is a specialty product. So the novelty here is like, let's do something useful with carbon. Click. So what could we do with that? Well, let's make the right form of carbon to slash those CO2 emissions from industry and transport that I was talking about just before. And the last click. But for that, you need to have the right efficiency, the right cost, and the right policies in place. So why is it possible now? So let's move to the next slide, please. 30 years ago, it would not have been possible. But in the last 2 decades, research and technological developments have unlocked pathways to new forms of solid carbon, such as carbon nanotube graphenes. And these forms of carbons have attributes and properties that overlap with those of metals, such as strength, thermal and electrical conductivity, flexibility or stiffness, depending on what to do or what you want to do. So now you really can have solid carbon materials that are used in a diverse range of products, from wiring, beams, panels for cars and buildings, to soil amendment for farming, entering markets that represent tens of millions of tons every year and slashing those emissions coming from industry and transport. So in the next slide, so how do we make it happen? How do we accelerate this transition? So cross-sector collaborations are required to take efficiencies up, costs down, and establish these new supply chains, which is why in 2019, Rice University established a Carbon Hub to bring together industry, academia, and federal labs. And it was launched with a $10 million commitment by Shell and additional funding by Prysmian and Mitsubishi Corporation Americas. We have also established a vast research ecosystem with over 80 partners in over 20 different organizations across the world. Last year, we awarded over $1.3 million in research projects. And this year, I think the anticipated budget is going to be over $2 million for research projects. And we are going to be announcing 2 extra corporate partners very soon. Next slide. So to enable this bold transformation, how we use hydrocarbons, the Carbon Hub comprehensively articulates and integrates 4 key areas: community building for the research, for the scientific community, education and workforce development, policy to ensure that policy development and technology remain in sync, and research. So the goals of the Carbon Hub are very well aligned with several of the goals by the United Nations, because we advance clean hydrogen with no CO2 emissions, and we advance carbon materials which are lightweight and can displace materials that have very bad footprint when it comes to energy and CO2. So we're decarbonizing the industry sector and improving the efficiency of the transport sector. And I will leave you just with one project that we're working on, the next slide, to show how we're creating this future. So Dr. Mark Grothrop is an architect at MIT that is building a house entirely made out of carbon materials. He's receiving some funding from the Carbon Hub and significant funding from the Department of Energy. And so the last slide is, will you join us in enabling this future? Thank you for your attention.
Thank you, Marie. Ralph, over to you.
Yes, thank you. Can you hear me? Okay. Thank you very much to the French-American Chamber of Commerce for having us today, for giving us this opportunity. Thank you, Laurent, for moderating this exchange. So I'm here to talk to you about Nextine, which is, let's say, the polymer side of the energy transition. We try to provide solutions, and that's the goal of this presentation. So Demeta is a French company. We are based in the western part of France, and we are developing catalytic technologies. And we are using these technologies along 2 program platforms. One, I will just go over it very quickly. That's the one on the right side, Green Care, which is developing specialty chemical solutions using the oxidation of alkenes technology, and with applications in flavors and fragrances, cosmetic and pigments. So not really the topic of today, but I thought it was important to mention. Nextine is the other program platform. We are developing through Nextine a family of high-performance materials using the olefin metathesis technology. It is at different maturity stages depending on the applications, and we are aiming at end markets, which I will detail in a few minutes. Next slide, please. So what pain point do we solve? One very important word that I noticed in Laurent's introduction is enabling. And we believe that Nextine is basically enabling solutions where incumbent materials, existing materials are, let's say, reaching their limits. 2 examples. One is the ultra deep offshore. We were exploring and producing oil from 300 meters depth. We are now at 3,000 meter depth and more. That's involving higher pressure and also higher temperatures of the fluids that are pumped. Another example, so obviously that is creating technical challenges in terms of thermal properties, in terms of mechanical properties as well. The other example on the right is linked to wind energy, especially with the growing share of offshore wind. The size of the blades, the size of the rotors is ever increasing, now reaching, this slide is actually already outdated, is already increasing to more than 100 meters. And that is creating technical challenges for the processing of those blades, typically made by epoxy, and epoxy is really becoming a limiting factor in the manufacturing of those extra long blades. So many industries are really reaching the limit of their existing materials, and they are looking for alternatives. And we hope that strongly believe that Nextine will be enabling and solving those issues. Next slide, please. So what is Nextine? Nextine is basically, I believe, the polymer of the 21st century. And why that? Because it's really combining the performances of thermosets, which are typically associated with temperature performance and rigidity, associated with the performance of thermoplastics, which are typically known for their toughness, and also combining with anti-corrosion properties, which are typical of fluoropolymers. So basically, it means that the engineers, the designers, don't have to compromise, don't have to make any trade-offs between the properties of the material they want to use. So we have here on the green line, you have the scope of performances of Nextine compared with other typical materials. Two points on the right side, I've mentioned already thermal properties and mechanical properties, but on the right side, two very important aspects. First of all, our technology is not the wheel in terms of processing. We are using existing processing methods for plastics. So it's either already available at converters or simply available off the shelf at plastic converting equipment manufacturers. And the next point, very important, is that the industry is looking for reducing the carbon footprint. The good news is that Nextine is basically cutting the carbon footprint of polymers by half. Can you please switch to the next slide? This is an example comparing the carbon footprint of Nextine versus epoxy, which is our closest competitor, I must say, in terms of carbon footprint, and we are slashing the carbon footprint by half. Why is that? Simply because we are upcycling a naphtha cracker byproduct, so we use the full value of a monomer which is otherwise flared or underutilized. But we're also processing these monomers through a very mild purification process. What I mean by mild is low temperature, low pressure. The formulation itself, the formulation of the resins that we will deliver to our customers, is also a very mild process. No fancy process. It's a mild mixing formulation technique at low temperature and low pressure. And then at the customer site, where the polymer is actually processed, the process is also a low energy, low temperature process using catalytic technologies. And last but not least, you are creating with Nextine a very lightweight polymer with a density of 1. Next slide, please. So the polymer is enabled by our breakthrough catalytic technology. So the know-how of the company is in the catalysts, but it's also in the formulation of the two-component liquid system that we deliver to the converters. So converters can be of two categories: either a classic plastic part manufacturer, which is molding parts and delivering it to OEMs, but it can also be processed on site at service providers, and that's very typical to the energy sector. We are using a fabless model, meaning that we can easily localize the production of our systems wherever it's needed. So we can produce our resin in South America, in China, in Europe, or in America very, very easily. Next slide, please. So 3 potential markets. We are particularly active in the oil and gas, which is of course let's say expandable to green energies and also carbon capture, with the manufacturing of very performant pipe and field joint coatings, custom coatings of subsea structures or offshore structures. We are also involved in risers and developing composite solutions. Composite solutions also used in the storage of hydrogen, either mobile or static, and a variety of applications in building and civil engineering. And then on the right side of the slide, let's say a bunch of applications such as body panels, ballistic protections, and so on. We are still at the startup phase, but we have a very promising early commercial traction with the first sales done last year and significant clients engaged in JDAs. You can see some logos on the right with Total, Subsea, Technip, Saipem, involved in through the CTEF in a multi-year program to develop specific pipe coating and field joint coating applications. We are also involved in a very interesting program with, at this stage, confidential, but very, let's say, very well-known partner. And together with this company, we are developing a novel class of materials for in situ thermal insulation. And we are also involved with a tier 1 global auto suppliers to develop 700 bar pressure hydrogen tanks, unraveling the technical limitations of epoxy. Then coming to the conclusion slide, we believe that Nextine and Demeta are really at a very strong market momentum. We are putting on the market a truly disruptive technology with a high potential. And our team is, let's say, available for application development, for joint R&D. We believe very strongly in joint R&D programs, such as the ones we have with Total and the engineering companies that I've mentioned before. And last word, I will leave it to Paul Anast, who is a professor at the Yale University. We are partnering with them and using the 12 principles of green chemistry that he announced a couple of years back. Thank you, and I hope that I will be able to answer your questions in a few minutes.
Thank you, Ralph. Let me just say first that I fully agree with your statement on materials and why they're needed to push boundaries. I think you have seen we are working a bit together, but same as TechnipFMC, we are really trying to push, the limits of our materials to be more resistant, greener, lighter, etc. So working on composites, obviously, on new polymers, and we look at things a bit together on graphene, and other new materials elements. I see we have one question in the Q&A that has been typed. Let's hope it's going to be a nice breaker. In case there is not necessarily a lot of questions, I have tons of questions for our panelists, so it's not an issue. We'll have a good discussion, but please, feel free to ask what you want. So the first question is for you, Marie. It's 2 parts. First part is what price of natural gas you need for the Azure hydrocarbon splitting to be profitable, basically, a little bit on the economic viability of this Azure hydrocarbon. And the second part is if the RISE Carbon Hub involved in policy and technology for carbon storage.
Thank you for the question. So I'll start with the second part. So one of the pillars of the Carbon Hub at RISE is the Baker Institute, which is a premier think tank in the world. It's actually the #1 university affiliated think tank for energy resources. So we're working closely with the Baker Institute, and they work on policy development. And so they have really 3 axes they're working on. One is CCUS, carbon capture, utilization, storage, and they're working very closely with the governor of the state of Texas in that area. The second one is nature-based solutions, They're working, that overlaps a little bit with the carbon hub because we're also looking into that. And the third one is the carbon hub, which is this approach of using hydrocarbons to make materials. So not per se the carbon hub, but since we're working with the Baker Institute, yes, there is a connection with Rice University and developing the right policies to enable carbon storage. When it comes to the first question, I was trying to figure out how to answer it because it's really a matter of also at what cost can you sell your hydrogen, at what cost are you selling your solid carbon. And so I cannot give you a definite answer. What I can say is that right now, the solid carbons that we're talking about are sold at like a little bit over $100 per ton. So that's quite expensive when you want to penetrate a very large market. But it means that it is profitable to start from natural gas and get to the solid carbons. And there are startups working in that area, and you have them across the world, in Russia, in Japan, in Israel, and also here in Houston. So I cannot disclose that price, but what I can tell you is that Shell has been looking at it very carefully, and they see a lot of benefits in pursuing this approach. So I'm happy to talk more offline if you want, Deborah. Thank you.
Thank you, Marie. So maybe I'm gonna turn over to Pierre. You know, in my introduction, I talked a bit about this challenge around scalability, accelerating time to market. So could you, on your side, tell us a bit if the technologies you have presented, what's a bit their scalability for, major onshore and offshore players, and what is their maturity level as well, and how do you see that evolve in terms of its scalability and market potential?
First of all, we usually don't develop technologies. I mean, we select the best in-class technologies answering to a given problem. And if tomorrow a next technology emerges and is more performing on the economic or environment side, which happens several times already, we just choose it. So we're not married to any technology. Then, to onshore, one of the problems we typically solve is a paraffin problem that are widely spread. I don't think there are many operators, at least in the west of the US, which doesn't face at some point paraffin issues. So the scalability is pretty large because as far as I know, there is more than 1 million wells in the US alone which face paraffin problems. And that means there are hundreds of millions of tons of water every year of fresh water, which are wasted and warmed, by the way, on site, which to clean paraffin. And then you dump, thousands of tons of xylene, which is carcinogenic and toxic, to continue fixing the paraffin. And you do that every month. So is it scalable? Yes. The plasma pulse is another example of very scalable technology because the microfracturing property of the plasma pulse treatment, which goes not very far. Typically, it's not fracking, it's microfracturing, the near wellbore, 3 to 4 feet. But that makes your permeability on the near wellbore much higher. So your flow of fluids is faster and your treatments go deeper into formation. So your squeezes are much more efficient. And this is the type of issues that at least half of operators in the US are facing. I would be more prudent about offshore because a number of the techs we use may not fully apply to offshore. And some of the techs would not apply to horizontal wells yet. So the plasma pulse, for example, it works very well in vertical wells. We use it very often. We have designed with our supplier a version of plasma pulse for horizontal wells. It's only a year away from today. But yes, it's highly scalable because the problems we have are the problems that everybody has.
Okay, thank you, Pierre. Ralph, maybe a question for you. You've shown us how Nextin is absolutely wonderful and matching, all the properties and improvement you can bring. But if you could highlight, one or two of the best or most disruptive properties you want to bring to the industry, why would you, what would you highlight in Nextin, disruption? What it is that that's really innovative and disrupting for you? You're on mute, Ralph.
Yeah, the topic of today being energy transition and green energy, I would at first cite the fact that we are cutting the carbon footprint of polymers by half. That's an obvious highlight of our technology. Then I would say the second one would be to provide a solution, a polymer solution which combines exceptional mechanical properties and thermal properties. It's usually either or, and this next team is really providing the best of both. And the third one, if I may add one, is the fact that it is with a very easy process. You can do extremely complex parts, extremely large parts, and without, as I said, easily with an easy process, but also with a low capex. It doesn't take hundreds of thousands of dollars or millions of dollars to invest in tools or in molds. All is done at low pressure. All is done at low temperature, and it really makes things easy, including the manufacturing of large, complex parts or custom coatings.
Okay, thank you, Ralph. Marie, a question for you in the chat. Any viable option of Azure carbon to replace copper wires? Very specific question. Don't know if you have looked at copper wires and option for that, but
yeah, thank you for the question. So yes. When we talk about replacing metals, we do envision replacing copper, steel, aluminum. So, but it's currently the performance of the materials are good enough to replace carbon fibers, to be used in specialty wearables and in some high-end electronics. And so that's the goal, is to have these small-scale plants in place within the 5 years, producing 3,000 tons per year, and then to penetrate those markets, which will be like 10 to 50,000 tons per year and equivalent to $1 billion per year. But we keep improving the properties. We need to improve the properties a little bit more to get to displacing copper, because eventually you want to get there. And the holy grail, what we call the holy grail, is displacing steel in structural applications. So there are pathways, and the Carbon Hub is working on solving those issues to make it feasible. Yes, thank you.
thanks. Question for Pierre. Is there any well already in operation with BIM technologies?
There are more than 300.
Wow.
Okay. Thank you, Pierre. And if I can add something, so is there an impact today on oil and gas prices, basically on what you do, and how it could boost, or on the contrary, slow down maybe your development?
Well, because we focus both on cleaner and more efficient technologies, we are less impacted by the low oil prices. And because we are on acquisition mode, because we still have a lot of gunpowder, we like low oil prices. I'm not too happy, frankly speaking, about prices going over 60, because it makes acquisitions more expensive. But I mean, we have LOE about $10 for oil, which is pretty low. So even when oil was very low in last spring, well, we didn't suffer too much. And that allowed us to make some very nice deals, because of course A&D pricing last year were pretty attractive.
Okay, thank you. And Marie, so you talked a bit about the funding and the first batch of projects that were funded, and next batch for this year. Can you give us some examples of projects you have funded?
Sure. So last year there were 7 projects funded through pooling the membership fees together, and 2 extra projects directed by one of the companies very specifically. So among those 7 projects, there is one team led by professors Maciello and Cohen at Rice University, who are looking into the the impact on atmospheric CO2 of using methane-derived carbon in soils. So we believe that you can introduce solid carbon in soils and then have a CO2 sink for atmospheric CO2. Another project also led by a Rice team, by Professor Wendmeyer at Rice University, is looking into how to replace metal-powered transmission cables with carbon nanotube fibers. And the last one I wanted to highlight is the Carbon House by Dr. Mark Gothrop at MIT, which is this very ambitious project of building a house completely made out of carbon materials. And we hope that we could then move the Carbon House here on Rice campus, and it would be phenomenal to have, to be able to show that you can make this happen. Thank you.
Thanks. Ralph, question around green gas. So are you looking to expand your business around green gas? Is it something on your roadmap?
It is definitely something on our roadmap. Basically, wherever it will be necessary to increase the longevity of the network, either piping network, or also storage, especially in green gas where there is inherent increased corrosion potential. That's definitely a market for us. Same goes for carbon capture and storage. Many sources of CO2 are involving sulfuric content, involving higher corrosion, and there we are also, let's say, providing solutions.
Okay, and any other business areas you'd like to highlight in terms of potential for you guys?
You mean in the energy sector or in general?
Even beyond, yeah.
Even beyond, yes. We are active in a variety of applications, composites or non-composites, where this, let's say, extended range of properties are sought for. So we are active in very large body panel applications. We are also heavily involved in ballistics, in the anti-ballistic field, either for the staff or for vehicles. So yeah, a number of applications outside energy or CO2 storage.
Okay, thank you. We have more a comment in the Q&A session around the electrical grid in Texas and what has happened, but I would like to prioritize to give time to our panelists to talk about what they do rather than maybe expanding on this topic where we all we're maybe out of power for 2-3 days, but that's not really the topic of today, I think. Pierre, if I can turn it over to you, could you tell us maybe what are the 1, 2, 3 technologies you are the proudest to use today?
Well, the one we love most is the plasma pulse, definitely.
Okay.
There were some providers in the US, but at bad pricing, very expensive, and not with very efficient tools. At some point, I spent part of my career in USSR at this time, and then Russia. So we turned back to Russia, where it was discovered, and had some suppliers build a fit for purpose American norms tool. This has been 2 years of very hard work, but now we are probably the only owners of proprietary plasma pulse tools, and this delivers incredible economics, and this is absolutely clean. And the nice thing with this kind of products is that you can combine it with another clean tech, for example, the acid replacement, because of course you don't want to dump your tool, which costs a bit of money, into classical acid, but we can dump it into the quasi-acid because it doesn't attack metals. And so we do the treatment and we do a squeeze with acid replacement immediately afterwards, and that's a killer app. So results are just mind-blowing with some sometimes production doubling, tripling after the squeeze. So that's one we love a lot. One which is very simple and basic, which is thermotreat. It's just circulating water from the well up hole and back down hole after heating to call it 200 Fahrenheit, maybe 180 down hole. But you do the same thing as hot oiling, but A, you don't waste fresh water. B, you are sure your water arrives down hole at least 180 degrees, while when you do hot oiling, you don't know what the temperature down hole, especially if you're a deep well, like 8,000 feet. You're not sure your water is still hot. And the beauty of it, again, you can combine it with another green tech, say the terpenes, for example, which will clean trap paraffin. And you are absolutely green treatment for paraffin. A third one that we like a lot, of course, is the nanoparticles, because a number of gas wells have what is called aqueous phase trapping. So basically, it's relatively dry formations with a limited water saturation. And then when you start to drill them, then you wet them, and then you block the gas. And use of certain type of nanoparticles, I will not name which ones exactly, allows to unlock aqueous phase trapping and have a very significant increase in production. And of course, the carbon footprint of those nanoparticles is very close to zero. And we use practically no water to do that. So that's all technologies that make you money and are very clean. And that's just 3 out of the 1 we use.
Okay, thanks, Pierre. Ralph, just out of curiosity, but are you active in Houston and in the US? Do you plan to expand here? I mean, what's your goal and ambition in the US?
Yes, we start to be active in Texas and with several contacts initiated, by the way, by the FACC. So thanks to them again. Yeah, we are in touch with a couple of companies to start using our resin systems. In fact, last week we had a first batch tested in not in Texas but in a neighboring state of Louisiana with quite good success. So yeah, we are active and
Okay.
we are open to discussions with any companies that is willing to test and evaluate our polymer, which will be really a game changer.
Okay, thank you. And maybe to conclude, because we have less than a minute, but Marie, you know, you said at the end, please join us. So just tell us, what does that mean? And for your members and people who maybe want to join, what success look like for you and your members, you know, in the next few years?
So join us. Well, we are looking for corporate partners along the potential supply chain. So from the energy providers to the people who do the semi-finished products to the end users of these new materials. And the two partners we're going to be announcing, one is going to be an energy company and the other one a chemical company. So that's very exciting. But we're also looking to expand our research ecosystems. So if you are an academic researcher whose research is aligned with the goals of the Carbon Hub, please do not hesitate to contact us. We keep adding more and more people. Right now we have universities in the United States like Berkeley, Stanford, Minnesota, Georgia Tech, in France, Université de Bordeaux, in the UK, University of Cambridge, in Italy, in Spain, and we're going to be expanding South Korea. So yes, we want to really bring the world experts around the table. And if you're a community member, you're interested in understanding how hydrocarbons can actually be part of the solution during and beyond the energy transition, please come talk to us. We'll explain to you it's not either or, it can be both. And what is success? So for us, success is in the next 5 years to put in place a small scale plant that would be producing 3,000 tons a year of this specialty solid carbon. And it's a very important step because it's the first step that you need to establish a reliable source of solid carbon and make it economical. And then you start learning how to take your, to improve your process efficiency and take your cost curve down. And what is success for our corporate partners? It's really answering their needs and priorities with a world ecosystem of researchers, and the corporate partners decide where the research goes. They pick the project. So you leverage and de-risk your corporate investment by joining the Carbon Hub. You figure out what are the right things that can take you at very large scale from hydrocarbons to hydrogen and value-added solid carbon.
Okay, thank you. I think we are, it's the end of the webinar. I don't know, Leah, if you had a particular conclusion, but at least I would like to thank all of you for attending. Thank the panelists as well, Marie, Pierre, Ralph, thank you very much. And again, thank the Texas FACC for organizing the webinar.
Well, thank you all. Same here. I'd like to thank all the speakers. It was a great conversation, discussion. I hope you all enjoyed it. And if you like to receive an invitation to our upcoming webinar, I'd like to invite you to go on our website and subscribe to our newsletter, so you will be up to date to what's going on with the FACC and the upcoming events. Thank you so much, and have a great day. Thank you.